Good morning, everyone. Welcome to class today. So today we are continuing with sectional views. But before I start with that, are there any questions on anything we've done up to now? No, today is not manufacturing. If you check the daily timetable, then you would see today is sectional views. So the reason for that was when I did the planning for the semester, I felt that it made more sense to do sectional views now so that we get through that stuff. Okay, so basically with the tolerances question, a tolerance is basically a dimension. Remember, we give dimensions, not that you can make the drawing to the correct scale, but we give dimensions that someone else can actually manufacture the component. So then on a dimension, let's say a specific dimension is crucial to the functioning of a component. An example of that would be like that laser pointer of mine, where the cap at the back has to fit into the laser pointer. Then the fit between the two is actually quite important. So I can now specify on the dimensions how much that dimension is allowed to deviate from the value I specify. So I can basically give the manufacturing company a ballpark in which they are allowed to deliver the parts in. So tolerances are basically just designed for that purpose, to specify a ballpark within which a dimension is allowed to vary. Okay, so I see a couple of questions about the fillets and rounds. Let me quickly spend 2 minutes on that. Just give me a couple of seconds to open the camera and share my screen. Okay, good. So fillets and rounds. Basically, what it was about was I need to be able to draw something the way I would actually see it. So if I have a component which had a plane tangent to that, I'm assuming this is the fillets and rounds that you are asking about. So if I want to draw a right-hand view of this component, it's important to note the location where the tangent line actually makes contact to the radius. These lines are just this flat surface, and now I'm going to draw a tangent surface. So now we'll note that I can actually see, or there is a perceivable height difference between the point of contact and the top surface. So when this inclined plane is drawn, I can actually physically see that it's going slightly past that line. And the same on the other side, slightly past the line. And now the fillets and rounds basically just says that this component is most likely cast, a manufacturing process casting. So casting means that none of the edges on this component can be sharp. It has to do with if you have your container and the molten liquid flows in from the top, because it's a rather viscous liquid, like it's a thick liquid, like a very thick oil almost, it means that it doesn't like to flow into sharp corners. So if you have a very, very sharp corner, then that corner will not be properly filled with your molten material. It just doesn't like to do that. So on cast components, they usually give roundings on all of the corners. So this component, which is rounded pretty much this tangent face meets that radius, we can show the rounding with a line like that, just to show that it doesn't just end sharp. There's actually a little bit of a gradual thing from the one to the other one. And obviously the same happens on the inside. Something like that. Now for the top one, again we can notice a slight height difference between the top of the component and where this thing makes contact. So it won't go all the way to the top before it makes its little rounding. So those rounds just indicate that it is two features that kind of blend into each other. It's not a very, very sharp thing. So I think that's the best way to put it. With rounds, the components blend into each other. Okay, so if we had a smaller radius, and still had a tangent line to those radii, then if the radius becomes small enough, then I won't be able to notice the height difference like we did in this previous example. So because I can't notice the height difference, then we blend it with a little radius and come down. At the bottom we blend it again with a little radius. But now I don't have this case where it was going past the edge. The height difference is too small to actually be able to draw with this size of pencil. So the standardized way to then show this is to let the tangent plane just come onto this vertical plane, but to show that there is a slight kink there where the pencil is pointing, to show that there's a slight rounding there. It's not a very gradual rounding like this one, but just to show that it isn't a sharp corner. We then use our thin pencil to just make a little line like that. So it's basically just ways in which you can draw different components that blend into each other. That's basically the whole fillets and rounds thing. And you can then go and study that slide to understand when you will do the small line. Basically, if you have a small radius and something blending into the small radius, the open one that goes past is for a very big gradual radius and a tangent line to that. And you can check the other ones. It basically also has to do, like I mentioned, with when you have two cylinders. Two cylinders that are intersecting each other. If the one cylinder has a very small diameter compared to the other one, then then this hug around the big one. So you have a cylinder there and another cylinder meeting it. Then the small cylinder won't really tend to wrap around the big cylinder because the diameter is too small. So then you won't see a little bulge there. But if we now go to a bigger cylinder, then we can now see this is the outside edge of the cylinder, and the point of contact is somewhere a bit further around than that, somewhere there. So it will start to wrap around or hug around the bigger cylinder. And then we start to draw this radius bigger and bigger. So it's basically just draw what you see. Okay, I hope that answers that question. Let's start with today's lecture slides then. So this is sections exercise 2. Just a quick overview from the previous lecture. We had, up to now we've done external views, but sometimes there's stuff going on the inside that we want to show. This is a very basic example, so it wasn't really necessary for a section view. But if there was anything not perfectly cylindrical about the internal details, then the hidden detail won't be sufficient to show what's going on. So then we said we can cut this thing open to see what it looks like on the inside. Remember, these lines are called hatching lines, and they are basically used to show where the component is solid and where the component is hollowed out. For example, if we cut through this hole over here, we will cut solid material to the left and right of the hole, but the hole itself will not have any cut marks inside of it. Same with the big cylinder in the middle, and again the other cylinder on the other side. Okay, so that's a full section view used to show internal details. Then we said another trick that we can do is make use of something called a half section. So that is where we draw a full external view and a full section view at the same time. So the left half could be in section or it could be the external, and then the other side is the section or external, basically not what the other side is. So we can have a section and an external view in one. Usually half sections are used for symmetric objects. So we show two views with the effort of half a view. Well, one view, but half a section view. Then we said a revolved section is used to show the cross section in a small location where the cross section doesn't vary in that distance. So the exact location of the section view is not critical. On the right hand side there, we've got the partial section, which we're going to look at again later today. Then we looked at removed sections, and this is just a variation of the removed section. So in a removed section, we do indicate exactly where the section takes place, but we don't have to place the section view in there like the revolved section or project it straight to the top like the sections. So as the name says, we can remove the section and place it somewhere else. So this is just a quick exercise to match the section view to, well, the section line to the view it could have created. Okay, so let's have a look. At the top there, we've got a circle in the middle, a cylinder in the middle, and two wings on the sides. This has one big thing in the middle, so no, not that one. Okay, cylinder through the middle with wings on the side. So A and 4 can correspond. I'm going to skip B for now. Let's go to C. Section line C should be solid in the middle and have little blank portions on the edges. So solid in the middle, blank open spaces on the edges. You'll notice that these removed sections are partial views, meaning like for view number A, which corresponds to 4, we don't draw all of this sloping information in the background. We don't draw it there. So we won't have those blocks on the outside. The reason for that is a removed section is used to show the cross section in a specific location, and we don't really care about anything other than that cross section. So this is actually what we call a partial view. So a partial section. Okay, so C and 5 work together. D is a slot, so it's a big opening in the middle with solid on the sides. Okay, that would be a big opening in the middle. There we have the two center lines for the two circles and solid on the side. So D, delta, and 2 work together. E has solid, hole, solid, hole, solid. But the holes have something weird going on. It's a big circle and a small circle. So it could be that there's a step or a cone or something in there. So E could be number 1, but then the big and the small circle won't make sense because this one is solid, cylinder, solid, cylinder, solid, solid, cylinder, solid, cylinder, solid. But it doesn't have the second circle available, so it can't be number 1. It is actually number 3. So we have a little bit of a cone and then a small cylinder going straight through. And B is then corresponding to number 1. The thin lines we'll do later on in this course. Okay, so let me quickly show you why a removed section is handy. If we do full section, like just a projected top view for each of those section lines, then it will create a lot of views above an already tall component. So this is not very practical with our A3 papers, which are landscape orientated. So what we can do is then label each of those section views and move them to the side. So that just makes much better use of the space on our page. Yes, the arrows show exactly that. The arrow shows from where we are viewing. So for number A, we are viewing it from the top, so that would be a top view. So yes, that's exactly what it does. The next kind of section is something called an offset section. So the hatching lines are for the entire section view, they are consistent, but these are all different views. So it's almost like saying it's a top view, a right-hand view, a left view, and a bottom view, except that these are just all different top views. So that's why the hatching doesn't have to be the same for all of them. But because it's one cut, section AA is one single cut, the hatching lines are consistent throughout the entire view. Section BB, it's one cut through, so the hatching lines are consistent for that entire view. So it's not really a crisis if they aren't all in the same direction. These are actually different views. Okay, section. If we have this component and we do a full section through the middle, then the full section view, section AA, would look like this. Solid at the top, then the whole, then solid at the bottom. Okay, let me just quickly answer the questions. So yes, basically the second part of your question, we won't specifically ask you to, in words, define what a revolved section does, but when you make a drawing, you need to understand where you can apply what kind of a section to be able to give all the information required for manufacturing or assembly purposes. Meaning you must understand them, you don't have to be able to define them. Okay, so a full section through the middle will yield this section AA. But you'll notice at the bottom we just have a big solid block. So we're not really adding information at the bottom of this view. So an offset section is basically a trick where we can have two section views, the one through the center of the component and a section view through this hole or that hole in the same view. So what we do is our section line comes down, then it jumps to the back and goes down again. So if we view it there in the direction of the arrow, in the top half we'll see the section of the top of this component through the big hole, and in the bottom part we'll see the section through that hole there. So it basically allows us to do two section views in one. Section view for the top and a section view for the bottom. Please note, because the location of that step, the vertical location of the offset, isn't really important, then there's no point in us drawing a solid line where the step took place. The location of the step is visible in the view in which the section is indicated. So we don't show a solid line over there. So in general, no, it won't matter whether you go through this hole or that hole. The section view will look exactly the same. So in this example, it doesn't matter, but in other cases, there might be a situation where you want to specifically go through the one rather than the other, and then you just indicate it with your section line. In this example, it doesn't matter. This is just some random example. If we cut through there and then do the offset and then go down again, then the section view FF would look something like this. We have the section, so solid, hole, solid, open air, solid, hole, solid, open air, and then the step goes to the back and completes the bottom half. And you can even have multiple steps in that line. So this is just a random example. So the arrows point perpendicular to the section line. We're actually going to do in the next section type, I'm going to show you that the arrows aren't actually always parallel, but they are always perpendicular to the section line. So they basically let us view this line perpendicularly so that we can line. Let me show you what I mean. If you look at my pencil, we can determine the length of the pencil because we are looking perpendicular to the pencil straight from the top. Now, if I want to measure the size of something or dimension something, I have to do it in a perpendicular view. If this pencil was now at an angle and I then want to, sorry, I'm just trying to grip this thing in such a way that we can all see. So the pencil is now pointing slightly upwards. So if I now want to dimension it you'll see that it's actually a lot shorter than what it used to be. So we can only dimension something in a view where we are looking perpendicular to the line. So that's why it's important in our section view that the arrow is perpendicular to the line we are viewing. Well, technically, it would make sense if they are inside of the sketch, because then we actually show what's going on the inside and not on the outside. But they don't have to always do it that way. You might get part geometries like that bizarre example where it isn't necessarily always inside of the sketch. Okay, the next section type is something called an aligned section. So these are usually used for cylindrical objects if a full section does not show all the internal detail. You'll notice there I have my vertical section line. Now in this one's case, that section line from top to bottom will give the same information both at the top and at the bottom. If I quickly draw it out for you, so if we do a full section view through this component, there we have section line AA. Then you'll notice when I draw hatching lines, I always try to make the lines line up, so I don't do all the top and then all the bottom. Okay, so that would be section AA. Now, at the top and the bottom, we're basically showing the same information. Let's say we wanted to do a section through these holes. Okay, so we're viewing it now from this direction. So there we have section BB. Okay, so again, now we're showing the slot in section, which is good. But in this view, we're also doing the top and the bottom. Basically, it's the same thing shown twice. So what if we can combine section AA and section BB into one view that does the one at the top and the other one at the bottom? Then we could do section CC, which looks like that at the top, the viewing perpendicular to the arrow. Now this bottom part of this line, we're viewing according to the arrow, perpendicular to this line. So the aligned section principle is then to take this section line and fold the image down so that I can draw it in the correct angle over there. So I'm basically drawing what I see if I view this portion of the line perpendicularly. So there's the circle, then we've got the top of the slot, bottom of the slot, and the bottom of the component. Still same hatching all the way through. Section CC. So this is basically a combination of two section views into one. But because the arrow is perpendicular to the section line, I draw what I see perpendicularly. So basically that half I place over there. Well, basically, we try to keep drawing views in the normal orthographic orientation. So this is not a standard way to do it. It is not wrong, not at all incorrect, but we would prefer that you place the views to the right or to the top or something like that. So don't just place views everywhere. It will get very confusing if you do it that way. So for a slot, there's a center line for the one circle and a center line for the other circle, which means if we view it from the side, there will be a center line for the one circle and a center line for the other circle. That's why the slot has two center lines in it. Okay, cool. So that's basically the aligned section view. It's used for cylindrical components where a full section does not show as much information as what you would want to show. It's basically a combination of two views, similar to what the half section is a combination between a full section and an external view. And a line section is a combination between a straight, straightly projected section view and a angle projected section view in one. Let me just quickly show one other thing. If we did a section view DD, you'll notice the difference with D now is that the arrow is pointing horizontally to the left. Then it would actually look a little bit funny. The top is still straight onto that section line. But now the bottom is looking at an angle. There's the outside of the component. And this external part of the cylinder is now that blank portion at the bottom. So you'll notice if the arrows aren't pointing perpendicular to the section line, then we have a pretty useless section view. Perpendicular to the section line. Okay, so just an example of this. A full section AA would cut through the middle. The section BB now cuts through that one spoke of the wheel and the other spoke of the wheel. Now, I'll get to why these are not hatched in a moment towards the end of this lecture, but doing this wheel in section BB just tidies up this weird slanted background information. So it just makes the drawing easier or simpler to read. Okay, next kind of a section is called a partial section. So usually if you have solid, let me just quickly check the question. Okay, show DD again. So DD is now horizontal arrow on the section line. The top will be the same. The bottom will now be off center of the circle, so that side won't be as long as that side. Then the slot, then this bottom portion, and then the open thing in the background. So that's a completely useless drawing at the bottom there. I can't dimension anything because everything is kind of at an angle. No, as I just said, section view DD is a pretty useless view, so I won't ask you to draw useless stuff. I just showed it to show what will happen if you do the arrows wrong. Okay, so solid components. A solid component like a shaft. Shaft is basically, if we take this little screwdriver, this metal part of the screwdriver is cylindrical, and it is solid all the way. So for me to make a section view of something that is solid is kind of pointless, because the whole point of a section view is to show what's going on the inside. A solid component has nothing going on the inside, it's just solid material. So then there's a rule that says for solid components like a shaft, you would in a section view typically not section the entire thing. It's going to make you add a lot of lines but not add any information to the drawing. But what you can do, if there are local regions where there is internal detail, you can make use of a partial section to just break out that section and basically just do a section view on a part of the drawing. Yeah, so that is a partial section. It's very handy if you have components with a little bit of info on the inside but not a lot going on. Okay, so we saw partial sections before in our Conrad example. In this example, this on the right hand side was a partial section. Okay. Some examples of partial sections. On the right of this shaft, it is solid, so there's no point in us making a lot of lines in there to show nothing. So I just use a break line. You'll notice the partial sections are always constrained by a freehand wavy line to show that it's broken out. It's just a section view. It isn't the part that's physically broken. So wavy line, there's the stuff I need to show. To the right, there's nothing for me to show. At the end of the shaft there is a hole going through, so I make a partial section there, and in the middle there's nothing to show, so I don't bother. So partial sections are basically used to tidy up the drawing and make it less line or time intensive and cleaner to read. You'll notice that with a partial section, we don't indicate the section line. So in this example, we cut through that little hole, but we don't know if it's the bottom one or the top one. It could be any of those two. For this part, we cut through a hole. There is no hole over there, so this partial section goes to the middle. This partial section is either at the bottom or a bit higher. So in partial sections, we don't show the depth. You can usually just assume the location based on the size of the feature. So if we project the lines upwards, we can see that it could be this one, or that one also corresponds to the same size. So it could be any of those two. If they were different, then obviously it might be beneficial for me to indicate it that way. So partial sections defined on one view does not have to be on the same plane, and they may be used on more than one view. So towards the end of this course, or basically between test 1 and test 2, we are going to start with assemblies, which is basically an assembly of components. So you draw many components put together. For example, like this screwdriver. This isn't a single part, it is an assembly of parts. There we have the metal part, the little shaft. There we have the body. Over there we have like a gripping mechanism to put it in your pocket. Over there we have a cap, and there's a little metal dot and whatever. So this isn't a piece made of one material. It's an assembly of components. So when later on when we draw this, we can make a section view through this screwdriver to show how everything is assembled on the inside. So yes, we will be making section views of assembled things, but we won't draw them separately. We'll draw everything as the assembly is already done. In this example, this is almost like a cap. So inside there, it is actually hollow. That's why the hatching shows solid over there, but hollow over there. So yes, good, it is hollow. So you can add hidden detail to a partial section view, but it depends. You won't add hidden detail inside there. You would probably, if you wanted, you could have added hidden detail to show the hollowness of the feature. Something like that is okay. So a view containing partial sections can have hidden detail, but the partial section itself should not have hidden detail. Okay, good. So that brings us to the next part, which is webs and ribs. So many times a part has support structures in place, which are relatively thin, flat support structures, like this one over there, the one on the other side, and these two in the middle. So there's a convention when making a section view through those. So to not give a false sense of thickness, these features, even though we are cutting through them, are not hatched if the cut is in the same plane as the rib or web itself. So that is called a web. The vertical and the horizontal one are both webs, but you'll notice it's thin in the one direction compared to the other two directions. So if you cut the section line such that the plane of the section lies in the plane of the web, meaning you cut the thin dimension even thinner, then there's a rule that says we will not hatch those parts. So as we cut through there, there, and there, and there, then we will not hatch those. And the reason being is if we cut through them and hatch everything, we make it look like this thing is one big solid component with a uniform thickness, where if we don't hatch the web when we cut through it in the plane in which it is already thin, then you are able to give this width dimension over there, which you won't be able to do otherwise. So it basically just shows that these non-hatched blocks are material, but they are thin. So if you cut a thin, flat shape even thinner, we do not hatch those parts. This allows us to show that there is actually a difference between the thickness of the thin, flat part and the web that lies in the other plane. So this is the thin, flat part. This is the web in a perpendicular plane. Okay, so we don't hatch those. And again, this allows us to show more information with less effort, which is one of the fundamental things of technical drawing. This is just another example. So here we have a wheel. It's got 3 ribs and a little cylinder in the middle, and then it's flat around the outsides with little holes in it. So if we make a full section view, you'll notice at the bottom part we're not cutting through a web, we're cutting open on the side and on the other side, just with solid material in the middle. Solid material, solid material, there's the hole. So solid, solid, hole. There we're not cutting through anything. At the top, we are cutting through the rib in the plane in which it is already thin. We're making the rib basically even thinner. Then what we do is we do not hatch those parts of the rib so that we can show that there we have a thin solid part. These parts do exist, but they are actually very thin in the plane in which we cut through them. So it's almost like if you cut, which allows you to show that the flat disc on the inside is constant in thickness all the way through. Okay, in this case we used a full section and not an aligned section. In this case, an aligned section will show the same information at the bottom and the top. So a full section in this case shows different information at the top and the bottom, which is more beneficial. Okay, so here we have class example. This is sections exercise 1 number C. And I've made a YouTube video available which shows the drawing of this section view. In the example, section view A is a section view from the other side, but that's not really the important thing. Section view B is what is discussed in detail and which I would think is a good idea for you guys to go check that video out. Yes, exactly. The whole idea of making hatching is to show where it is solid. So there's no point in making something that is hollow look solid by putting hatching in there. So if there's a gap in the object, you don't add those little parallel lines in there. Okay, good. So as I mentioned, there is a YouTube video. The link is on your lecture slides tab on ClickUp. There's a link there, and there's also a link in the online video tutorials to this YouTube video that shows how to make the section view, especially noting we are cutting through a web. Okay, good. Any last questions before we end this session? I see someone has raised their hand. You're welcome to ask a question. I'm glad it was nice. I really do try. So for some of the pracs from last week, it wasn't marked yet. The one marker let us know at a very late stage that he had a stomach bug and wasn't able to do his work. So please give us another day or so, then that marking should be done. So the top of that section view basically says the white block on the right and the white block on the left are the rib, but because we're cutting through the rib in the plane in which it is already thin, so we're cutting it even thinner, we do not show the rib there because then it will just be one big hatched block at the top, and by not hatching it in the rib, we are actually able to show more information with less effort. Thank you, and you guys as well. So typically a web and a rib, hubs or plates are webs, and on the inside of a wheel you'll have ribs. That's basically the definition. Okay, any more questions? Yes, this session is recorded and should be available in about 20 minutes or so after the session has ended. So in this example, the full section is from top to bottom, so it goes through the rib at the top, through the hole in the middle, through the hole at the bottom. And a lined section in this case will go through the rib, through the hole, through the rib again, which will show the same information twice. The recordings, if you go on to ClickUp, on the Collaborate tab, in this black Sessions tab there, click on those three lines for the menu, and there you can find the recordings. Okay, I think I did answer this question a minute ago. So let's quickly draw something. We like to draw stuff. So let's consider that part in the example as a cylinder and a flat disc, and obviously the small cylinder on the inside. So if we add those together, we get a component that looks something like that. And then after that, we added the ribs. So now we added these little support blocks in there. Just want to check. Okay, we have 5 minutes left on the session, then it will automatically close. Okay, so now we add these supports to our drawing. So that's basically the rib. It's just a little support block we add to strengthen the component. Now when we made the section view, we cut through that rib and viewed it from the side. And that's how we got to the flat disc in the middle, the rib on the sides, flat disc with the hole in it, no rib visible over there. Okay, so that's basically how this thing is comprised of. Comprised of 2 cylinders and a flat disc and 3 ribs. So when we made the section view and we cut through the rib, we cut through it in the plane in which it is already thin. So we want to not kind of lose information if we hatch the rib. So by not hatching the rib, we can show the flat disc on the center, where if we hatch the entire thing, we would lose that information. So not hatching the ribs in this case allowed us to show more information. I hope that kind of makes sense. ClickUp does usually keep register of who attends which lectures. So if I wanted to, I'm sure I could get that information from somewhere. It's a pleasure. Okay, then any last questions before we're automatically kicked out of the session? Okay, I have to leave. I just remembered I have another session with other students. Thanks for attending, guys. Have a good day.